We're going to be taking differentiation. Okay, we'll look at gradients. Okay, and then we'll take a lot of questions. And then the next episode will be equations of tangents and normal. Y, let's say you have y, we have y as a function of x, okay, to power a. You have this type of expression. The derivative, which we call the y, the x, will be equal to the power will go to the front, the expression minus 1. That's the general formula for differentiation, where this, the y, the x is called derivative, or we call it differential coefficients, coefficients, gradients, okay. These are the names for the y, the x. Let's take the equation. Let's say you have y equal to, it could be theta. Your y is a function of theta. So we are going to differentiate this y respect to the given function, respect to theta, and that will be the y, the theta. Okay, so that will be equal to the n will come to the front, the function itself, and then minus what? Minus 1. So in a nutshell, you differentiate respect to the given function. You differentiate respect to the given function. You could have t equal to pn. Okay, it's not necessarily y. So this will be equal to what? The t, the what? The p, and that will be equal to what? The same thing. The power might not go to the front, and then this one minus 1. So that's that on derivative, differential coefficients, gradients. So that's that on these aspects. You have if y equal to, you could have a times x to power n, where your a is a constant. Where your a is a constant. You could have your expression in this form. Okay, so the y, the x is the same as what? Y prime. We can also write our y as f of x. We can write our y as f of y as f of x. Okay, so is that clear? Your y is the same as f of x. So this will be equal to the power will go to the front, and that will be a n x to power n minus 1. Okay, your a could be positive, could be negative. So that's that on this form. Another thing we need to note is this: when you have y is equal to sum or difference of function, sum or difference of function, your derivative, your dy dx will be equal to derivative of each of those functions. Derivative of each of those functions, and that will be f prime of x plus or minus g of what? G of g prime of x. Okay, so your f prime of x is the same as what? D dx of that function. Okay, your g prime is the same as what? D dx of that function. Okay, so when you have sum of functions of difference of functions, the derivative will be derivative of each of those functions. So that's the question we have here. Given that y equal to 8x cubed plus 3 over root x plus 5, and we are told that x is greater than 0 that we should find the y, the x. Okay. What we do first for this question is to do the algebra. Okay. What does that mean? Let's remove these square roots, this radical. So that will be 3 times x to power minus half. 3 times x to power minus half. Okay, and then plus 5. Plus 5. So the y dx will equal to, as we said from the beginning, your a is 8. So this 3 times the one you have here, the 3 will go to the front, and then x to the power 3 minus 1, and then plus the same thing here also here. This minus half will go to the front, and then x to the power minus half minus 1. Okay, and then when you differentiate a constant, and I didn't mention that when you differentiate, if y is equal to c, is a constant. Okay, the y dx will be equal to what? Will be equal to 0. So when you differentiate a constant, it will automatically give you 0. To give you 0. So that will be plus 0. So we're going to have 24, and then x to the power 2, 3 minus 1, and then this one will be minus 3 over 2, then minus half minus 1. That will be x to the power minus 3 over 2. So that's that on that. But we can go on and do the algebra. Okay, so that will be minus 3 over 2 times this minus is 1 over x to the power 3 over 2. Okay, and that will give you 24 x squared minus 3 over 2 x to the power 3 over 2. And that's that on that aspect. Okay, that's that on that aspect. That's that on that aspect. As you're coming in, just begin to say I. Just begin to type say I as you are coming in. If you're yet to subscribe, please do that straight away. If you have your own question, please type it on the comment section. Okay, you are highly welcome. We have a lot to do in these segments. We're going to look at gradients. Okay, we're going to look at second order differential. Okay, differentiate this. We're told to differentiate this. We have 2x cubed plus square root of x plus x squared plus 2x over x squared. Before we can do this, we need to do the algebra. Okay, and if we like, we can give it a name. You can call this one, let it be y, if you like. Okay, and if you don't like, you can just say ddx of the given function 2x squared. So that's the solution. 2x squared plus, remove the radical, that's x to the power half, and then plus, do the algebra of this one. This one implies x squared over x squared plus 2x over x squared. That's the rudiment. That's the first thing to do before you differentiate. You do the algebra. Okay, so then we can continue ddx of the expression 2x cubed, okay, plus x to the power half. Okay, this one will be 1. That's a plus 1. And then this one will be plus, this we cancel. That will be 2 over x. So after the algebra, then you can now differentiate. And when you have derivative of sum of functions, it's going to be derivative of each of those functions. Derivative of sum of functions or difference of functions will give you derivative of each of those functions. And that will be derivative of this one. That will be ddx of this plus ddx of this plus ddx of this plus this one will be ddx of, we can break this one up, that will be 2x to power minus 1. So this will give you, the 3 will come to the front, that will be 8, the power minus 1, plus this one, the same thing also, the power will go to the front, the expression, minus 1, okay, and then plus derivative of a constant is 0. Then the same thing you do here, that will be what? 2 times minus 1, and then x. The power here, minus 1, that's minus 2. Okay? If you missed the yesterday live section, please check my channel for derivative, how to, definitions of a derivative. Okay? The foundation has been laid. Okay? The first principle, principle has been explained to get derivative. Okay? And we have done a lot of questions, and we have started with the using the standard results, using general formula to do differentiation. I think we've laid the foundation yesterday. So if you missed the yesterday video, please check the channel, the live section of yesterday on definition of what? Of derivative. Okay, so let's go on. So this will be equal to this one plus half minus 1, that will be equal to what? That will be equal to minus half. Half minus 1 is minus half, and then minus 2x minus 2. That's your answer. But you can do efficiency. You can do over efficiency. You can do the algebra. Okay? You can do the algebra, okay, and get the complete answer. Some question will, you can leave it this way. To leave it this way is okay. There's no problem. So let's tidy the negative. So that will be what? Half times the minus there is 1 over, and that will be what? Root x. And then minus what? 2 over x squared. So this is a perfect. That's your answer to the question. That's your answer to the question. For the first one, we are told to find the y, find the y dx when y equal to a, we have y as this, b, we have y as this, c, we have y as this. Let's quickly look at that without wasting time. The first one, number 1, y is equal to what? 2x squared minus 6x plus 3. So the y dx is the same as y prime, and that will be equal to what? The 2 will go to the front, that will be 4x, the power minus 1, that's power 1, which is anything to power 1 is that number. Okay, then this will be equal to what? 6. The power here is 1, so that will be 6 times 1, and then x to power 1 minus 1, and then this is a constant. If you differentiate 3, that will give you 0. So we have 4x minus 6. 1 minus 1 is 0. X to power 0 is 1. So this is your answer for number 1. Number 2, y is equal to the second one, b, y is equal to 8x squared plus 7x plus 12. Okay, if you differentiate this, your y prime, which is the same as the y dx, will give you the power, will go to the front, that's 16x plus what? Plus 7. So that's the question in the comment section. Okay, and if you need one-on-one on any of your courses, just I'll put my email on the comment section. Send me an email, then we can meet via Zoom, Google Meet, and so on and so forth. Okay, it could be good discussion, and it could be one-on-one. Okay, it will be tailored to your materials, to your course. Okay, as you're coming in, just begin to say I. Question 2, we have find the gradients of the curve whose equation is 1, 3x squared at the point this. As I've said earlier on, the gradient is the same as the y dx. So differentiate this one, that will be 6x. This one will go to the front, okay, and then the power minus 1. At point what? At point 2 comma 2. At point 2 comma 12. This one mean x, this one mean y. So there's no y in this equation. We only have x, and that will be equal to what? 12. So let's go to the b part. The gradient, the y dx, is equal to what? Differentiate the function. This is a 2x squared. So these two here, we go to the front. That's a 4x, the power minus 1. If you differentiate x, is having this is having power 1. So the 1 will go to the front, and then the expression, okay, the power minus 1. So that's 1 times x to power 0. And anything to power 0 is 1. So this is what? Minus 1. When you differentiate minus 1, that will give you 0. At what? At 2 comma 5. Okay, x is 2, y is 5. So this will be 4 times 2 minus 1, and that's 7. That's 7 for that one. Yeah, we have this equation. Find the y coordinates and the value of the gradient at the point P with x coordinates 1 on the curve with equation y equal to 3 plus 2x minus x squared. So that's what we have here. Okay, that's what we have. We have the we're trying to find the y coordinates. We know the x coordinates as 1. That's 1. The 2, we're trying to find the gradients. Okay, at that point P. Okay, the gradients at that point P, which is the y the x. Okay, find the y coordinates. We have the y equation as 3 plus 2x plus minus x squared. We're given x is equal to 1. Okay, plug in that. That'll be 3 plus 2 times 1 minus 1 squared. So this one will be 5 minus 1, and that's what? That's 4. So the point P now is 1 comma 4. When x is 1, y is 4. 2, we are told to find the gradients, which is the y, the x. The gradient is what? If you differentiate 3, that will be 0. If you differentiate 2, 2x, there is 1 here. So this one, we go to the front. That's 2 times 1. Write the expression 1 minus 1. Okay, and then minus 2x. The same thing also, this one will go to the front, the power minus 1. So this will be equal to this one, 1 minus 1 is 0. X to power 0 is 1. So we're having 2 times 1 minus what? Minus 2x. That's the gradient at the point, at point x equal to 1. So this will be 2 minus 2 times 1. So that will be what? That will be 0. So the gradient is 0. Okay, for that equation. So if you differentiate this one, that's 2 minus 2x. Then you put your point there. So that's that on this question. The 2 questions are similar. I'm going to do one. I'll do the first one. You try the second one and put the answer at the comment section for the second one. I'll do the first one. Put the answer for this one at the comment section. For the number 4, for 4, find the gradient of the curve. Find the gradient of the curve. Y equal to x squared minus 5x plus 10 at the points A and B, where the curve meets the line y equal to 4. Okay, what this means is this: there is an intersection of the curve. this one, y equal to intersect with this equation, with this curve also, y equal to 4. So what you're going to do, you're going to equate, since there is an intersection of the curve, you're going to equate the functions together, and that will be equal to wherever y, we place 4 there. So that will be 4 equal to x squared minus 5x plus 10. Then make it a quadratic equation, move this 4 to the other side, and that will be equal to what? S squared minus 5x 10 minus 4, that's a plus 6, equal to what? Equal to 0. So we're going to find two factors of 6 that can give us minus 5. Two factors of 6. Factors of 6 is 2 and 3. Okay, 2 and 3. So it could also be 5 and 1. But 5 and 1 be useful. 6 and 1. 2 and 3 as the factors of 6, or 6 and 1. But the relevant one in this case is 2 and 3. Minus 2, minus 3. And when you multiply those two factors, it's going to give you plus 6. So it's going to be what? Minus 2, minus 3. Equal to what? Equal to 0. So this is equal to 0. This expression also is also equal to 0. So x is equal to what? X is equal to 2 or 3. So that is the 2 points we have. Okay, the 2 points A and B, at the points A and B. Then we need to get the gradient of this curve. Okay, at that point. Okay, let's get the gradient. The gradient will be equal to what? The y dx, which is the gradient, will be equal to, these two will come to the front, that's a 2x minus what? Minus 5. At points A and B, which is a 2 or 3. Okay, so the gradient could be 2 times 2 minus 5, that's minus 1, or 2 times 3 minus 5, which is what? 1. So that's your answer for that question. They said the curve meets. So if the curve meets, that means the y will be equal together. So this will be 2x squared equal to x plus 3. Then you can make it quadratic equation. Okay, minus this. Then you can factorize now. The factorization is the main thing, but it's very simple. This one times this one, that's minus 6x squared. Two factors of that, okay, of minus 6, they can generate minus 1. Okay, they can generate minus x. So that will be minus 3x, and then plus 2x. Okay, that's the two factors. And when you multiply these two factors, it's going to give you minus 6x squared. Okay, then you can now replace the middle one, and that will be equal to what? 2x squared minus 3x. Okay, let's make it plus 2x. Okay, then minus 3x. Okay, and then minus 3. Then you can begin to pair these two, the first two and the last two. 2x is common, so you have this one, and then here and here minus 3 is common. You have x, minus times minus, that's a plus 1. So this and this must be the same. So it's going to give you x plus 1 times 2x minus 3 equal to what? Equal to 0. So x is equal to minus 1 or 3 over 2. So once you get the point C and D, then you can get the slope. Your slope is 4x. Then substitute those points. I'll do the first one, do this one, and put the answer in the comment section. I'll do the first one, do the second one, and put the answer in the comment section. Put the answer in the comment section. Okay. For the first one, We have this f of x is equal to x cubed minus 9x squared plus 24x minus 20. So that's what we have. The gradient is a derivative or differential coefficient, which will be equal to the power. We come to difference, the same expression, the power minus 1, then minus 9 times 2, that's 18, and then 2 minus 1, we have this, and then plus 24. Okay, then we are told that the derivative, the gradient is what? 0. So we're going to have 3x squared minus 18x plus 24 equal to what? Equal to 0. If you're just coming in, just begin to say I. If you're yet to subscribe, please do that right now. I'm going to share the links of this video across your different platforms, your Facebook, your Twitter, and so on and so forth. Okay, then we can reduce this equation by dividing through by 3. Divide each one by 3. So we have x squared minus 6x plus, this will be 8 equal to 0. Okay, then you can find the factors of 8. Factors of 8 is 4 and 2. Okay, you can also use 7 and 8 and 1. But 4 and 2 will be applicable in this case. This is a plus 8. So this will be minus 4 minus 2. So x minus 4, x minus 2. So x minus 4 is equal to 0, or x minus 2 is equal to 0. So x is equal to 4, or what? 2. Okay? When x is 4, come back here. When x is 4, put it here, substitute there. So that will be equal to what? When x is 4, y will be equal to 4 to the power 3 minus 9 times 4 to the power 2, okay, plus 24 times 4 minus 20. I think that will give you minus 4. You can check that. That will give you minus 4 to complete the coordinates. That will give you minus 4. Okay? So do for the, when x is also 2, get the y also, so you can get the coordinates, the points. So we have 4 comma minus 4, 4 comma minus 4, and 2 comma, you can get the other one, get that one. So that's that for that one. Okay, that's that for that one. Begin to type your comments. Do this one, the B part, in the comment section. Use standard results. Use standard results to differentiate. Use standard results to differentiate. Okay, the standard result is just to use the formula. So let's look at what we have here. The first one, a ddx, that's differentiation of this fraction, 2x plus 3 over x. So do the algebra, ddx into brackets. This fraction means 2x over x plus 3 over x. That's the first thing to do. Okay, I'll do the first one, you do the second one, and put the answer in the comment section. So this will be equal to ddx of 2 plus 3x minus 1. So, and that will be equal to, if you differentiate the constants, that will be 0, and this will be what? Minus 3 over what? Over x squared. Okay, so that's that for the second, the first one. This will be minus 1 times 3, that's minus 3, okay, and then the power minus 1, that's minus 2. So take it down. So that's that. B part, put the answer in the comment section. The C, we have ddx of the fraction, which means 2x cubed over root x plus 3x over root x. Okay, that's the first step to be taken. Root x means x to the power half. So this will be equal to ddx of 2. We're going to take this one up. That's x to the power half. This division, they have the same base. We'll take one of the bases, and that will be 3 minus what? Minus half. And then plus 3x. This is power 1. And then minus what? Minus half. Giving us what? Minus half. Okay? X of 2. This will be 5 over 2. 5 over 2. 3 minus half is 2.5. That's at 5 over 2. And then plus 3x minus half. Then we can now do the differentiation. The power times this one, 2 times 5 over 2. So these two cancel. And then x to power 5 over 2 minus 1. Then plus 3 times minus half. And then x minus half minus 1. That's minus 3 over 2. Let's just tidy the expression. So that will be 5. Okay, that will be 5. This will be x 3 over 2. Okay, then minus 3 over 2. Okay, x minus 3 over 2. I'll finish the C part. Okay, the D part, do that, differentiate that, and put the answer at the comment section. Differentiate the D part and put the answer at the comment section. Do the D part and put the answer at the comment section. So let's see between E and F. I'm going to take one. I'll take the F1. Okay, I'll take the F. Do this one also. Put the answer at the comment section. Differentiate that using the standard results. Differentiate that. For the F, we're going to do the expansion. I could use a product rule, but I don't want to do that. I want to do the expansion. Do the expansion before you now differentiate. Do the expansion before you differentiate. So this one times this one, that's a 12x squared. Okay, this one times this one, that's a 3x times 1 over x. And then minus 2 times this one, minus 8x. Minus 2 times this one, minus 2 over x. Minus 2 over x. Then you can open the brackets, open and close the brackets, and put the differential coefficients, ddx of that. Okay, so this one we cancel, x we cancel. Then we have, if you differentiate this one, that will be 24x. The power difference and the power minus 1. If you differentiate plus 3, that will be 0. Okay, if you differentiate minus 8, that's minus 8x. That's 8 minus 8. This one, this 2 over x is the same as 2 x to power minus 1. So that will be minus 1 times 2. That's minus 2. With this one here, becoming plus. Plus 2, plus 2, and then minus 1 minus 1, x minus 2. So if you like, you can take it down. And if you want to take it down, that will be what? That will be over x to power 2. Over x to power 2. Second order derivative. What does that mean? For example, you have y equal to, which is the same as f of x. Okay, I say f of x, and you have an expression. Probably you have 4x to power 5. Okay, and you want to get the second order derivative. Second order derivative means is a differentiation that will repeat itself twice. You differentiate first time and you differentiate second time, and that will give you second order derivative. Okay, so the first time y prime, which is the same as the y dx, and that will be f prime of x. If you are using f of x, equal to what? The 4 times 5 times 4, that's 20. And then 5 minus 1, 4. So this is the first order differential. This is the first order derivative. The second order, you're going to repeat the process again and differentiate second time. Okay. It depends on what you are using. If you are giving as a f of x, this will be your second order differential. It can also be this also the square y, the x square. These are all second order differential or second order derivative. Okay, this one times this one, that's 80, and then the power minus 1. So that's that on the first order and second order differential. Let's take questions on these aspects. The y, the x, and the square y, the x square, when y equal to this. The y dx is the first order differential. The square y, the s square, that's the second order derivative or differential. So we have the function. So let's go straight to the solution. The first one, we have plus 3x plus 8. The first differential, which is the y dx, will be equal to this 2. The 2 here will go to the front. That's 24x, the power minus 1, plus what? Plus 3. That's that for the first case. Okay, you're just coming in, just begin to say I and subscribe to the channel. Finally, share the links across your different platform. Thank you for doing that. Okay, the second one, the second order differential, you are differentiating again. You are differentiating again. Okay, which is will give you this one. That's the second order differential. Okay, 24x will be equal to what? 24, and then plus what? Answer 24. Okay, so that's that. You also try the number 2, but don't forget 2 over x. You can make it 2x minus 1 to make the differentiation easy for you. So let's go to the third one. Let's go to the third one. The third one, y is this 9. You can remove these square roots. That will be x to the power half minus 3x to the power minus 2. Bring this one up. So get the first differential, which is 9 times 1 over 2, and then half minus 1, that's minus half, minus 3 times minus 2, x to the power minus 2 minus 1 minus 3. So I'm having 9 over 2 times, this minus is 1 over root x, okay? 1 over x to the power half. So minus times minus, that's plus. That's a 3, that's a 6x minus 3. Okay, this one, let's since we are still going for the second differential, let's leave it in the exponential form. That will be x minus half. Okay, for that one. That's the first differential. Get the second differential. The second differential will be what? Y prime prime. That will be 9 over 2 times minus 1 over 2. The power will go to the front. And then the power minus 1, that's minus 3 over 2. Plus Minus 3 times 6, making minus 18. Okay, x minus 4. Minus 3 minus 1. And that will be equal to what? Minus 9 over 4 times x to power 3 over 2 minus 18 over x to power minus 4. And that's question. Okay, so also try this one, the D number 4. Do that in the comment section. 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 We're going to continue later in the day, okay, to look at the rate of change of a function, to look at equation of a tangent, equation of normal, and then we'll begin to take a series of questions, okay, series of questions, could be past questions, exam review, okay. Thank you for staying by. See you again later in the day. I'll update the time shortly.